Grade 12s, today we are going to master the art of drawing the graphs of vertical projectile motion. Fellas, let's ace it to the hilt. Let us start with velocity versus time graphs. Our type 1 is dropping an object. When the object is dropped from rest, the initial velocity of that object is 0 meters per second. The velocity increases as the object falls downwards. Velocity versus time graph for this object is going to be like this. Velocity is always on the y-axis, time is always on the x-axis. We are going to use a gradient to determine the slope of the graph we are about to draw. Let me ask you a question. What is the gradient of velocity versus time graphs? Hope you got it. The gradient is gravitational acceleration. The gradient of velocity versus time graphs is always gravitational acceleration. Let me tell you why. The equation of a gradient is changing y over changing x. On velocity versus time graphs, we have velocity on y-axis and time on x-axis. Therefore, the equation of a gradient is going to be changing v over changing time, changing velocity over changing time. If you remember, the definition of acceleration is changing velocity within a certain time. So our gradient is the acceleration. It's going to be gravitational acceleration since we are on vertical projectile motion. Gravitational acceleration is equals to 9,8. It's a constant. Free falling objects experience it. Another thing that you must know about it is its direction is always down. Now let us draw the graph of the object. The object was dropped from rest. The initial velocity of the object is 0 meters per second. So our graph is going to start at the origin. When the examiner said choose downwards as positive to draw the graph, the gradient, which is the gravitational acceleration, is going to help us determine the slope of the graph. The direction of the gravitational acceleration is always downwards. So when we choose downwards as positive, our gravitational acceleration is going to be positive. When the gravitational acceleration is positive, the graph is going to have a positive slope, meaning it's going to be like this. If the object hits the ground with the velocity of 10 meters per second, after 5 seconds, we are going to label down. Now let us choose up as positive. When upward direction is positive, downward direction is negative. So our gravitational acceleration is negative. When gravitational acceleration is negative, our graph is going to have a negative slope, meaning it's going to be like this. Now let us draw the graph of this object. The object is thrown vertically upwards with a velocity of 12 meters per second and it hits the ground with the velocity of 30 meters per second after 10 seconds. Now draw the graph. Choose down as positive. When downward direction is positive, our gravitational acceleration is going to be positive. Therefore, our graph is going to have the positive slope. This time, the graph is not going to start at the origin because the object is not dropped at rest. It is going to start at 12 meters per second. Our object is thrown vertically upwards at 12 meters per second. It is thrown upwards. Remember, we have chosen down as positive. If down is positive, up is negative. So the graph is going to start at 12 meters per second, that's negative. Gravitational acceleration is positive. The graph is going to have a positive slope. Let us draw our graph. The velocity at the maximum height is equal to 0 meters per second, so it is going to be here. Remember, the object hits the ground with the velocity of 30 meters per second.